Have you ever been listening to a track, maybe a guitar solo or even keys, and suddenly heard this incredible, almost liquid pulse?
Yeah, that kind of sound that seems to breathe in and out, swirling around the notes.
Exactly. It's not quite chorus, definitely not tremolo. It's something else. Really organic feeling. Adds this undeniable motion.
It really grabs your ear, doesn't it?
It does. And you might not have even known what it was called.
Well, that unmistakable movement, that sonic signature, often points to a really fascinating piece of gear, the phaser pedal.
That's it. And today, that's where we're doing a deep dive into the captivating world of the phaser.
Sounds great.
Our mission, really, is to unpack how this, well, seemingly simple effect actually works its magic.
And trace its journey, right? From being this kind of bulky studio trick to, well, a must-have stomp box for so many musicians.
Absolutely. And we want to highlight some of those iconic sounds that help create for legendary players. We'll explore the key innovations, the different sonic textures.
All the things that have made the phaser such an enduring staple in music.
Right, so let's start with the basics. The magic behind that whoosh, as you called it. What exactly is a phaser?
Okay, so at its core, the sound comes from using a series of cascaded all-pass filter stages.
Whoa, okay. Cascaded all-pass filter stages. Sounds a bit technical. Can you break that down? How do those filters make that swirling sound we actually hear?
Sure. Put simply, these filters are designed to shift the phase of certain frequency bands in your audio signal. Just nudge them a bit, timing-wise.
Okay, shifting the phase.
Yeah. And then when those phase-shifted frequencies get mixed back together with the original unaffected signal, what we call the dry signal, something interesting happens.
Oh, the mixing part.
Right. That recombination creates a series of moving notches, which are essentially dips in the audio spectrum.
Notches, like little frequency cutouts.
Exactly. And crucially, these notches sweep up and down the frequency range. It's that constant movement, that sweeping of the notches, that produces the signature whooshing or, pulsating sound.
Got it. That makes a lot more sense. Now, here's where I think people sometimes get confused. The phaser has a sonic cousin, right? The flanger.
Ah, yes. The flanger. They both swirl, but they're definitely different beasts.
So what's the fundamental difference? How do they get their sounds differently?
That's a really key distinction. Flangers work by using very short delay lines. Think tiny echoes.
Okay, delays.
And that process creates what are called comb filters, basically, a whole series of notches that are equally spaced across the frequency spectrum, like the teeth of a comb, sharp and regular.
Okay. Evenly spaced.
Phasers, on the other hand, because of those all-pass filters we mentioned, produce unevenly spaced notches.
Uneven. That's the key.
That's the key, and that unevenness is precisely what gives phasers their, well, often subtler, more musical kind of swirl. It's less metallic, maybe?
Yeah, I can hear that difference when I think about it.
Technically speaking, this means phasers typically have about a -20 dB per decade roll-off on those notches and can shift the phase up to -90 degrees. Basically, the frequency dips are broader, more gradual, smoother.
That's a great explanation. Really helps clarify the nuance.
No.
Okay, so we've got the science down, more or less. Let's rewind the clock. How did this effect go from the studio to the pedal board, the very first stomp box phaser? That was the Maestro PS1, right?
Absolutely, a true pioneer. Released back in 1971.
71, wow.
Yeah, by Gibson's Maestro brand. And it was actually a collaboration with a real visionary, Tom Oberheim.
Oh, Oberheim. Of synth fame later on.
The very same. The PS1 was built like a tank, this robust metal chassis. And it didn't have knobs, interestingly. It had 3 fixed-speed rocker switches, slow, medium, and fast.
Simple controls. And its original goal was pretty specific too, wasn't it? Something about Leslie speakers.
Exactly. It was explicitly designed to try and recreate that rich, swirling sound of a rotating Leslie speaker cabinet. That it often used with Hammond organs, but also guitars.
But in a portable pedal. That must have been huge.
It really was. Before that, getting that sound meant lugging around these big, heavy, often unreliable Leslie cabinets. The PS1 put that kind of sound within reach for, well, everyday guitarists and organists.
So it democratized that sound, in a way.
Precisely. It started bringing studio-level modulation out onto smaller stages and into garages.
Yeah.
Big impact.
So Maestro opened the door.
Yeah.
But there was another pedal, just a little later, that really blew it wide open, right? The one that ended up on, well, countless records and stages.
Yeah.
The MXR Phase 90.
Ah, the Phase 90. Yeah, you can't talk about phasers without talking about the Phase 90. It holds a really significant place. It was actually MXR's very first pedal.
Their first ever.
Yep. Designed in '72, and it basically launched the company commercially in 1974.
And its design was famously simple.
Almost ridiculously simple. Just one single knob speed. That was it. Housed in that iconic bright orange die-cast box. Instantly recognizable.
And the player most associated with it. The one who really put it on the map.
Has to be Eddie Van Halen, no question.
Right. He apparently just picked one up while on tour.
That's the story, and he used it to sculpt those absolutely legendary swirling lead tones on tracks like Eruption, Atomic Punk. I mean, the list goes on.
That sound became synonymous with his early work. It totally cemented the Phaser's place, didn't it? Made it essential gear.
It really did. It proved that sometimes, simplicity is key. That one knob delivered the sound for a generation.
A perfect example. So the Phase 90 set a huge benchmark. But MXR didn't stop there, did they? They went for something a bit deeper.
That's right. They clearly wanted to offer more control, deeper modulation possibilities, which led them to unveil the MXR Phase 100 in 1975.
Okay, Phase 100. How did that differ from the 90? More knobs.
More knobs and more stages. It was a 10-stage phaser compared to the Phase 90's, typically 4 stages, depending on the version.
10 stages, so a richer, denser sound.
Exactly. More notches sweeping around. Plus, it added a 4-position intensity switch alongside the speed knob. That intensity switch controlled the feedback or resonance of the phase effect.
Ah, feedback control. So you could make it more pronounced, more resonant.
Precisely. It gave players much more nuanced control over the depth and the actual character of the phasing, made it a favorite for people who wanted maybe a more lush or even a more extreme phasing sound.
And didn't Billy Corgan use the Phase 100 quite a bit? Like on Smashing Pumpkins' Siamese Dream?
Absolutely. His guitar tones on that album are drenched in effects, and the Phase 100 is definitely a key ingredient for some of those really thick, warbling textures. He really pushed what it could do.
So a more versatile beast. Now, 1975 was a big year for phasers, it seems, because another icon arrived then, too, right, from Electro-Harmonix.
Indeed. 1975 also saw the birth of the Electro-Harmonix Small Stone.
The Small Stone, another classic name. What was its approach?
It was also a multi-stage phaser, but it used a different technology internally. It was BBD-based.
BBD, Bucket Brigade Device. What did that mean for the sound?
Yeah, Bucket Brigade device. It was a type of analog chip that basically passed the signal along a chain of capacitors, like buckets in a fire brigade line. This allowed for creating the short, precise delays needed for modulation effects like phasing and chorus in a compact, relatively affordable way.
Okay. So it was an analog chip thing.
Right, and that BBD technology often imparted its own character, often described as warm, maybe a little bit lo-fi in a good way. The Small Stone definitely had that characteristic warm, liquidy swirl.
And controls. It had that color switch, right?
It did. It had a main rate knob for the speed, and then the color switch, which was essentially its feedback control, similar in function to the intensity on the Phase 100. Kicking in the color switch made the phasing much deeper and more resonant.
There were different versions, too, V1 and V2.
Yep, V1 came out in '75, and the slightly revised V2 appeared around '78. Minor circuit tweaks, different enclosures over time.
What's really cool about the Small Stone is how widely it was used. You hear about blues and funk guys loving that liquid swirl.
Definitely, very Leslie-like sometimes.
But then, apparently, country pickers used it for adding jangle and bite, which sounds kind of different.
It's surprisingly versatile. And then you had metal guitarists cranking the rate and color to get these huge whooshing jet plane swooshes.
Wow. From jangle to jet planes. That really shows its range.
It truly does. It found a home in so many different genres.
Okay, so we had Maestro, MXR, EHX. Who else joined the analog party around then? Bi-SS, maybe?
You got it. Bias entered the compact phaser market in 1977 with their PH1 phaser.
Bi-SS pedals always had that reputation for being built like tanks and, importantly, for silent switching. Was the PH1 like that?
Absolutely. Rock-solid construction, reliable FESI switching, which was much quieter than the mechanical switches on some earlier pedals.
Yeah.
The PH1 quickly became a workhorse.
And its design, simple like the Phase 90 or more complex.
Pretty simple. It was a straightforward 2-knob analog design, just rate and depth. Came in that original, slightly larger Bi-SS enclosure in green.
Great, not good.
And interestingly, the PH1 was actually one of the very first 3 compact pedals BOSS ever released.
Really? One of the original 3?
Yeah, it launched alongside the legendary OD1 Overdrive and the SP1 Spectrum pedal. So it really marked Bi-SS's serious arrival in the effects pedal scene.
That's significant. And it stuck around for a while.
It did. It was produced into the early 80s, and they even released a version called the PH1R, which added a resonance control, giving it a bit more flexibility like the Phase 100 or Small Stone.
Man, that was a golden age for analog phasers. These pedals really defined the sound for so many players.
It truly was. They laid the foundation.
So from those analog giants, let's jump forward a bit. Technology marches on. How did phasers evolve with digital tech and maybe some more out there ideas? Let's talk about Moog. They did something pretty different, didn't they? The Moog Fugger.
Ah, the Moog Fugger MF103. Yes, that was something else entirely. Introduced in 1999.
Moog, known for synths mainly. What made this pedal special?
Well, it was basically a semi-modular synth module in a stomp box format. It wasn't just a simple phaser.
Semi-modular. What did that mean in practice?
It meant it had incredible flexibility. It packed both 6-stage and 12-stage phasing options, selectable. It had a voltage-controlled LFO, the oscillator that creates the sweep.
Voltage-controlled,
Yep.
like a synth.
Exactly. And crucially, it had full CV gate inputs and outputs.
CV gate.
Yeah.
Control voltage.
Control voltage and gate. This meant you could connect it directly to modular synthesizers or other gear that use CV. You could use external signals to control the phase speed, the depth, the LFO waveform. Endless possibilities.
So you could integrate it right into a synth setup or use expression pedals in really complex ways.
Totally. It had this incredibly lush resonance control, MIDI capability for syncing and control, and just that deep synth-like tweakability. It was a huge hit, obviously with synth players, but also with guitarists and producers who really wanted that deep level of analog control and sonic sculpting power.
Almost a Phaser Plus instrument in itself.
Very cool. A real marvel of analog engineering in a pedal format.
Okay, so Moog took analog phasing to a new level of complexity. But then the digital revolution really hit pedals too. BSS came back into the picture with a digital phaser, right? The PH3.
Yes. Just a year after the Moog Fugger, in October 2000, BOSS released the PH3 phase shifter. And this was a big deal.
The first digital phaser.
First digital one, yeah. And it really leveraged the power of DSP, digital signal processing.
What kind of new things could it do that the analog ones couldn't?
Quite a lot, actually. It introduced features that were becoming essential for modern players. Things like tap tempo sync.
Ah, so you could tap your foot to match the phase sweep to the song's beat.
Exactly. Super useful live. It also had expression pedal control, so you could dynamically sweep parameters in real time. And it had multiple modes, 7 of them.
7 modes, like different types of phasing?
Yep. You could choose 4, 8, 10, or 12-stage phasing, like having multiple classic phasers in one box. Plus, it had these unique rise and fall modes, creating one-directional sweeps, kind of like a barber pole effect, and even a step mode for rhythmic, sequenced phasing.
Wow, that's a ton of options.
It really was. The digital engine allowed for studio-grade precision and this incredible versatility. You could dial in classic sound, sure, but also create much more modern, complex phase tones that just weren't possible with the older analog circuits. It showed where digital effects were heading.
So beyond these big names and the analog to digital shift, have phaser circuits themselves continued to evolve? Are people still finding new ways to make that whooshing sound?
Oh, absolutely. The story doesn't end there. There's been a lot of innovation, especially in the boutique pedal world. People are exploring beyond the standard BBD or op-based designs we've mostly talked about.
Like what kind of alternative approaches?
Well, you see things like optical phasers, for instance. The classic Univibe, while often debated if it's a true phaser or its own thing, used a light bulb and photocell's light-dependent resistors to create its modulation. That's a totally different mechanism.
Optical.
Yeah.
Interesting.
Yeah. And then there are designs based around JF transistors, or OTAs, operational transconductance amplifiers, which were used in some classic synths and effects. Each of these components has its own unique sonic character and quirks.
So different building blocks create different flavors of phase.
Exactly. Even going back, like the Univibe again, it used these classic Darlington buffered all-pass stages, but with opposite polarity transistor paths to generate the notches. Little design details like that contribute hugely to the final sound, that chewy, almost vocal quality the Univibe is famous for.
And modern boutique builders are running with these ideas.
They really are. They're leveraging powerful DSP chips for things like multi-band phasing, where you can phase just the low end or just the mids, for instance. Or they're finding new ways to use analog components, maybe combining different techniques, creating hybrid designs. There's a lot of ongoing creativity pushing the boundaries of what a phaser can sound like.
That's fascinating. So when we zoom out and look at this whole journey, What's the big picture? What does all this mean?
Well, it means the phaser has had this incredible journey, hasn't it? From that first Maestro PS1 trying to mimic a Leslie.
Through the absolute icons like the Phase 90, the 100, the Small Stone.
Right, defining sounds for rock, funk, metal,
hmm
then evolving with Moog's deep analog and Bauhaus's digital precision.
And now into this era of boutique innovation, exploring all sorts of new textures. It's painted music with so many different sonic colors.
It really has. Just think about it, that subtle shimmer you might hear on a clean guitar part in a pop song.
All the way to, yeah, Van Halen's Eruption. That sound is just pure Phase 90 power.
Or even earlier, think about Jimi Hendrix. While the Univibe isn't strictly just a phaser, that psychedelic swirl on things like his Star-Spangled Banner at Woodstock has that phasey, Leslie-like motion. It's been a constant presence.
So for you listening, whether you're a musician looking for that perfect shimmer or maybe that crazy mind-bending swirl.
Or even just an enthusiast curious about how these sounds get made, the phaser is just this amazing gateway to sonic exploration, isn't it?
Definitely. And it's amazing how those classic circuits, designs from the 70s, are still inspiring players and builders today.
Great design just endures. It proves that sometimes those foundational ideas are incredibly powerful.
It really is incredible. A single effect type with such a rich history and lasting impact. Which kind of leads to a final thought, doesn't it?
Where does it go from here?
Yeah. As technology keeps pushing forward, you have to wonder, will the digital phaser, with all its precision and flexibility, eventually just eclipse its analog ancestors?
Or there's something about the subtle imperfections, the warmth, that kind of intangible mojo of those old analog circuits, the BBDs, the OTAs that will always keep them special, irreplaceable.
That's a good question. And what other sonic textures are still out there, waiting to be unlocked by whatever the next generation of phaser designs might bring?